In order to export the animation to the game engine, I'm going to be using 3 rigs. The rig to animate the character will be made later. At the moment it's more important to get the prototype working, so the rig needs to be able to use retargeted animation as well as to be able to export my future custom animations. There are also issues with scale when using FBX, so I want to see if I can sort those out now as well. I'm going to start by creating a subnet and converting it into an HDA. I'm then going to lock all of the default transforms and hide all of the default parameters for the HDA. Next, I enter the HDA and rename the geometry node to character geometry. I enter the geometry node and then use an object merge node to bring in the character mesh. The first major decision is to decide whether or not I'm going to use a curve-based spine. I considered using the path tool like this and then using the resultant curve to both generate the spine and to control the animation. The problem with this approach is that the Unity humanoid character has a very basic spine, and the curve solvers in Houdini have rotation issues with only 3 bones. So instead I decided to use a simple bone chain. I use the bone tool in the side view and set the placement to 3-hand. Also want no kinematics, and I'm going to set the divisions to 3. The bones are not going to follow the curve of the spine, as the retargeting is easier with them in a straight line. After I've made the bones, I then rename the root null and name the bones to hip, spine and chest. Next, I make the head and the neck. Houdini does not have the best snapping when you're drawing the bones, so I draw them as close to the desired position as possible and then snap them to the chest afterwards. In the case of the head and the feet, I'm parenting a dummy bone to the chest and then copying the transforms manually. With the arms, I will use the snapping for the bone tool. I transform the construction plane in order to maintain correct rotation on the legs. Then, I draw the feet in the side view and align them with the end of the legs. Here I realized that I neglected to rename the neck and the head. I also took this opportunity to rename the bones of the leg. I renamed the foot bones, and then I started drawing the shoulder and the arms. The shoulder is drawn from the front view in order to have correct rotation. The arms, hands and fingers are drawn using the construction plane. The bones for the rig are now completed by using the mirror tool to mirror the left arm and leg. Once they are mirrored, I check that the new bones are named correctly, and then I'll move them to the opposite side of the network. I move the geometry node out of the way, select the bones and then create a subnet. The subnet is then duplicated and I rename the subnets to control rig and deformation rig. The control rig will be used to animate the characters in Houdini, and the deformation rig will be used to export the character. The hip bone is going to be the root of the rig. In order to do this, I simply delete the root null of the spine chain. Remembering, of course, to check the keep position when parenting checkbox in the properties of the hip bone. I will then organize the chains for the legs and the feet. After selecting the thigh and the foot bones, I activate the keep position when parenting checkbox in the property window. The leg root null and the foot root null are then deleted, and the foot bone is made the child of the shin bone, and the thigh bone is made the child of the hip bone. This is of course done for both legs. The purpose of this is to have all the capturing performed by a single rig that contains only bones. This will remove all unnecessary elements from the export process and simplify it greatly. I now repeat the process for the rest of the rig, and at the end there will be no nulls remaining in this rig. The rig is then finished by moving the mesh geometry into the deformation rig. I now have two skeletons that look identical but are structurally different. It is, however, a good idea to differentiate these rigs from each other visually. At the moment, all of the bones have different colors. For the deformation rig, this is a good thing, as when the mesh is captured, the capture weights will use the bone color. There is, however, no reason to have individual colors on the control rig. So I will start by making all the bones white. Then I will give a different color to the limbs on each side and to the bones in the center. Now comes the tedious part of this rig setup. Once I've finished the prototype rig, I will make a scripted rigging system for this, but at the moment I'm doing this manually. I start by entering a bone in the deformation rig. I then add a constraint network. I then add a blend node and an object node. And I set the target bone in the object node to be the corresponding bone in the control rig. After that, I will drive the bone length parameter in the deformation rig from the bone length parameter in the control rig. This way, the bones in the deformation rig will now follow the bones in the control rig. The bones have all now been constrained, and I will now make a duplicate of the deformation rig, and I will rename that to animation rig. We will then remove the mesh geometry from the animation rig. I can now easily export the animation without the mesh, which will make it far easier to iterate over the animation process. The final thing to do before exporting is to capture the geometry. To do this, we will select the geometry node, click on the geometry capture button in the rigging shelf. In this case I'm going to use bioharmonic capture, and then I will select the hip bone. With this being a prototype, this level of capture should be more than sufficient. Now we're going to export our rig. We'll go to Export, Film Box. We will then choose our destination for our rig. We'll click Accept. And then we'll click on the target, and we will then go into our HDA and we will choose the deformation rig. And we'll accept that, and then we just click Export. And now we can go over to Unity. Now that we have our rig in Unity, we have a problem. Dragging the model into the scene, we will see that our rig is way too small. The reason for this size difference is due to unit conversion. FBX was originally designed to bring animation in and out of Motion Builder, and therefore all its units are originally based off Motion Builder. There are two ways we can deal with this problem. Under the Model tab of the FBX file, the first option is Scale Factor, which will allow you to arbitrarily scale the mesh. Changing the scale factor to 100 will give you the correct mesh size. This, however, is an awkward way of dealing with the problem, and there is a better alternative. Below scale factor, there is convert units, which will also give you the correct scale when it is unchecked. During development, I will have to go through hundreds of versions of animations and model files, and it will be a waste of time to have to toggle this for every file I'm going to go through, so I'm going to be implementing a more permanent solution. To solve this, we're going to make an editor script. An editor script needs to be in the editor folder. We're going to create a new C# script, and in this case we're just going to call it mesh scale. Now we just open the script. It's going to be using Unity Editor, and we're just going to delete the start and update functions. This class is not going to be a mono behavior. It's going to inherit from asset post processor. Then we're going to call void on preprocess model. This needs to be spelled correctly. Then we are going to create a model importer, and this model importer is going to cast an asset importer as a model importer. And then we're going to go model importer, and we're going to use file scale, We're going to set that to false. We're going to save that. Now we can re-import the FBX files. If we re-import, we'll see that the convert unit now changes to false. And if we re-import a number of files, we'll see that they all are now set to false. With that now applied, the characters should now all be the correct scale. The next thing to do is to prepare the characters for retargeting. To do this, I will select the rig prototype and convert it to a humanoid, and then apply the changes. We will now configure the avatar, and as you'll see, it is not in the correct T-pose. There are a couple of bones which have not been detected properly, mainly in the chest and in the hands. I just fixed those quickly. Unity then crashed when I tried to enforce the T-pose. I restarted and did everything again, and then this time when I enforce the T-pose, you'll see that it pushes the character into the strict T-pose, and now this character can have retargeted animations. I'm now going to take the character I've imported and place it under control of the player. In the player prefab, I will delete all the old models and bring in the rig prototype. So now I drag on the rig that I've just exported from Houdini. And then what I'm going to do is I'm going to take the avatar that I have just made for this rig, and I'm going to replace the avatar in the animation controller with the new avatar I've created. And I will start the game. The locomotion is pretty basic at the moment, but as you can see, the animation is working on the new rig.